There are two main kinds of variation, direct variation and inverse variation. For direct variation, we're looking for keywords or key phrases such as y varies directly with x or y is directly proportional to x. In either case, you're going to see the word direct in the question. If we're looking at a direct variation problem, the equation that we're going to use is some variation of y equals kx. With inverse variation, we're looking for phrases such as y varies inversely with x or y is inversely proportional to x. In either case, you're going to see the word inversely somewhere in the question that will indicate we're dealing with inverse variation. And in that case, we're dealing with the equation y equals k over x. In both direct variation and inverse variation, k is called the constant of proportionality. The steps to solve a variation problem are 1. Write the equation template based on whether the variation is direct or inverse. 2. Use initial conditions to solve for k. 3. Replace the value of k in the template equation with the new found value of k. And 4. Use the completed variation equation to answer any remaining questions. The value y varies inversely with x. The keyword inverse means we're dealing with the equation y equals k over x. Now let's use the initial conditions to find k. When y is 9, x is equal to 4. Therefore, k must be 36. Once we find the constant of proportionality k, we can plug it back into y equals 36 over x. From here, we can answer the question. Find y when x is 2. Y is equal to 36 over, in this case, x is 2, so y must be 18. The distance s an object falls is directly proportional to the square of the time t of the fall. If an object falls 16 feet in 1 second, how far will it fall in 3 seconds? And how long will it take for an object to fall 64 feet? First, recognize that we're dealing with direct proportionality here. So that is y equals kx. Or if we want to, in this case, they're actually giving us specific variables to use. S is directly proportional to the square of the time. So we want to make sure we square the time. Once we have our initial setup, we can use given info to find k. An object falls 16 feet in 1 second. So distance is s, time is 1 second squared, divide by 1, and we get k is 16. Once we have our constant, we can plug that back into the initial equation. S equals 16t squared. Now the first question is, how far will it fall in 3 seconds? S is equal to 16 times 3 squared. 16 times 9 is 144 feet. The second question is, how long will it take for an object to fall 64 feet? Going back to our initial equation with k being 16, and this time we want the distance to be 64 feet. So s is 64. 64 equals 16t squared. 64 divided by 16 is 4. So 4 equals t squared. Take the square root of both sides, and our time is 2. Technically plus or minus because we're taking the square root of both sides, but in this case, we just want the positive time, so 2 seconds. Joint variation implies direct variation with more than one variable. So we're still using the basic direct variation. It's just direct to more than one variable. So we have our direct variation equation, but instead of being directly with just x, we can think of it as x and z. For example, y varies jointly with x and the square root of z. In this case, that would be y equals k x times the square root of z. Combined variation is just a combination of direct and inverse. For example, translate the phrase into a math equation. R varies jointly with P and Q and inversely with the cube of S. Y varies jointly with P and Q. Remember, joint is just direct put together, PQ, and inversely with the cube of S. So we have S cubed. The volume V of an ideal gas varies directly with the temperature T and inversely with the pressure P. Let's start with that and write an equation. Volume varies directly with the temperature T and inversely with the pressure P. Now let's use initial information to find K. If a cylinder contains oxygen at a temperature of 300 and a pressure of 15 atmospheres in a volume of 100 liters, let's use this info to find K. Cross multiply, we get 1500 equals 300K. Divide, and K is equal to 5. From here, we'll plug K back into our initial equation. Volume is equal to 5 times the temperature divided by the pressure. Now we can answer the question. If a piston is lowered into the cylinder, decreasing the volume occupied by the gas to 80 liters, so our volume is 80, and raising the temperature to 310, what is the pressure? Cross multiply. 80P is equal to 1550 divided by 80, and we get that our pressure is 19.375 atmospheres.